We move to question number 9, which gives us a power series of this form, and we are asked to find the radius of convergence. Now, in order to find the radius of convergence here, we notice that we have a power of n with x and a power of n square with the constant term. Now, in order to reduce this to a form where x is free from n, we have to take the nth root of the equation or the expression. So this is called the root test method. So this would reduce to limit n tending to infinity mod of n plus 2 over n whole to the power n square into 1 by n, because I am taking the nth root, multiplied by x to the power n multiplied by 1 by n. So this would be limit n tending to infinity mod of n plus 2 by n whole to the power n multiplied by x. Now we have x free from n and we can bring it out of the limit. So we'll get mod of x into mod of limit n tending towards infinity 1 plus 2 over n whole to the power n. This can be again written as mod of x multiplied by limit n tending towards infinity 1 plus 1 over n by 2 whole to the power n by 2 into 2. Now, why am I doing this? Because I want to get the expression in the form of e. Now, how do I get e? Now, we can write this expression in the form mod x mod of limit n by 2 tending towards infinity 1 plus 1 over n by 2 whole to the power n by 2 whole square. And this expression inside the parenthesis reduces to e. This whole expression limit n by 2 tending towards infinity 1 plus 1 over n by 2 whole to the power n by 2, this is e. So this expression comes out to be x mod of x into mod of e square, or we can write this as mod of e square x. Now we know that this expression has to be less than 1 for finding the convergence limits. So therefore e square x will lie between 1 and minus 1, and x would lie between 1 over e square and minus 1 over e square. So the convergence radius is 1 over e square, and option D is the correct choice. Now let me also show you how this limit reduces to e. Now we have limit n by 2 tending towards infinity 1 plus 1 over n by 2 whole to the power n by 2. Now this is of the form limit x tending towards infinity 1 plus 1 by x whole to the power x. Now we take this expression to be equal to y, and we take log on both sides. So we get ln y is equal to limit x tending to infinity. Ln of this expression will give us x ln 1 plus 1 by x, or we can write this as limit x tending to infinity ln of 1 plus 1 by x, and we bring this x down as 1 by x. So this is the form of an expression where we cannot put the value of x tending towards infinity, because that will result in an infinite value. So we have to apply L'Hospital's rule, which means that we have to take the differential of the numerator and the denominator, and if I take the differential of the numerator, it will be 1 by 1 plus 1 over x multiplied by 0 minus 1 x to the power 1 into x to the power minus 2, and the denominator will be minus 1 into x to the power minus 2. So this would be equal to, this term will cancel out, so this will be reduced to limit x tending to infinity 1 over 1 plus 1 by x. Now if you put the value of x as infinity now, this term will be equal to 0, so this term will become equal to 1. So ln y is equal to 1. So ln y is equal to 1. That means e to the power 1 is equal to y, or y is equal to e. So this is how the limit of this expression becomes equal to e. We come to question number 10, where we are given a matrix of the form 3 by 3, and we are told that the center of the group is isomorphic to which one. So clearly we can see that the center of the group of this one is 1 1 1. So this is the center of the group, and this would be isomorphic to which of the four options. Now isomorphism means that there will be an element x in the group such that x times any other element will be equal to a times x, or x plus any other element will be a plus x. So this is the property of isomorphism, and we know that any number multiplied by 1 will be the number itself. So 1 into x will be equal to x into 1. So therefore any number that is real, any real number will yield itself when multiplied by 1. So therefore B, which is the realm of real numbers, is the correct choice. So 1 1 1 will be isomorphic to the set of real numbers, which is option B. We come to question 11, where we are told that An is a sequence of positive real numbers, and L is defined as limit n tending to infinity an plus 1 over an. Then which of the following condition holds true? Now L is equal to limit n tending to infinity an plus 1 over an. Now an plus 1 and an are both positive real numbers, positive real. So we can say that an plus 1 is equal to an plus or minus a delta, which is the difference between an and an plus 1. So we can write L as limit n tending to infinity an plus or minus delta over an, which means that this can be written as limit n tending to infinity an over an is 1 plus or minus delta over an. So this is nothing but 1 plus or minus limit n tending towards infinity delta over an. Now, since an and an plus 1 are both defined positive real numbers, so the delta between them is a constant. The difference between them is a constant. So, which means that this limit or the value of L equal to 1 would mean that the second term, which is the limit term, tends to 0 as n tends to infinity. That means as n tends to infinity, limit of n tending to infinity an will tend towards infinity. An would tend towards infinity. So if L equal to 1, this means limit n tending to infinity an will be equal to infinity. So therefore we see that the first two options are ruled out because they are saying if L equal to 1, then limit an with n tending towards infinity is either 0 or 1, which is not true. So these two are ruled out. Now we have to check for the condition if L is less than 1. So if L is less than 1, that means 1 minus, we cannot have the plus condition there, so it would be 1 minus delta over limit n tending to infinity an, and this would mean that the second term or the term of delta over limit n tending to infinity an will increase as n tends towards infinity. So which means that the denominator limit n tending to infinity an would tend towards 0. Only then the whole term can tend towards infinity as n increases, because at for every value of n, the entire term 1 minus the second term has to be less than 1, which means the second term has to be positive. That means it has to go on increasing as n increases. So limit n tending to infinity an would be equal to 0. So option D is the correct choice.